welcome to this episode of our video class course. Like you all know, I'm Tutojo, the CEO of Success Team Tutorial. So in this video class course, I'm going to be talking about gas laws. Yes, this is going to be the part 1 of gas law, because gas law, we have a lot of things in gas law you have. So today I'm going to be focusing on Charles law, Boyle's law, general gas law, and ideal gas law. So just pay attention. I'm going to derive all the formulas for you. I'll give you all the formulas and I'm going to solve questions. Yeah. So now I'm not going to make this video too long, but at the same time it's going to be long. So now for Boyle's law, it says that pressure is inversely proportional to what? To volume. So I'm going to have P is inversely proportional to volume, Abi. Then I'm going to have P is equal to K if I add constant now over V, Abi, I cross multiply. I'm going to have PV equals to constant, Abi. This is what I'm saying was P1 V1 is equal to what? P2 V2. Yes, this is the formula for what? For Boyle's law. For Charles law, it is said that the volume is directly proportional to what? To temperature. So I'm going to have something like this. V is directly proportional to what? T, right? Yes. So I'm going to have V is equal to KT. If I divide both sides by T, I'm going to have V over T is equal to what? K. Which thing I'm saying was V1 over what? T1 is equal to what? V2 over what? T2. This is the what? This is the formula for what? Charles law. Take note of that. Now for general gas law, it's just the combination of what? Of Boyle's law and Charles law together. Just combine them, and if you combine them, you get something like this. I don't want I can derive it though, but I don't want to waste too much of our time. So I'm going to have V1 and P1 V1 over what? T1 is equal to what? P2 V2 over what? T2. If you look at T2, you know that it's a combination of the two formulas. So this is what? For general gas law, the formula for general gas law. Yes. Now for ideal gas law, there's a formula. We have PV is equal to nRT. R is called the molar mass constant. And you should know that N is this is a very important formula. Please take note of that. You should know that N is the number of moles. A number of moles is N is going to be equal to mass over the molar mass. So I can actually replace this N if I want to, and have PV is equal to M over our capital M RT. This is another massive formula, very important. It's really helpful. Or I can also say, okay, I can just say, let me decide to cross multiply. I'm going to have PV M is equal to M RT. This M is the molar mass, this M is the mass. You understand? Yeah. So now let's use all these formulas to solve question massively. Let's solve this question. I'm going to be solving a total of 5 questions, so pay attention. So in this question they said that calculate the pressure at 27 degrees Celsius. Calculate the pressure, so that's not find pressure. I'll show the question on your screen. Calculate the pressure at 27 degrees Celsius. So T is what? 27 degrees Celsius. But I have to convert it to Kelvin, you know now. So I'm going to add 273 to it. So I'm going to have 300 Kelvin, right? Calculate the pressure at 27 degrees Celsius of 16 grams of oxygen. So the mass of oxygen is what? 16 grams. Unit was at 16 grams, right? 16 grams of oxygen gas occupying 2.5 dm cube. So the volume here is what? 2.5 dm cube. And in bracket they say that R is equal to 0.0821. Yes. Now they asked us to calculate the pressure. Now if you can remember, I gave you a formula. I told you that PV is equal to nRT. I also told you that in case if you can see now, N is not given. No. N is not given, but M is given as 16. Abi, M is given as what? 16. Yes, but and they say that it's oxygen. The mass that is given is the mass of oxygen. Abi, yes, and we know the molar mass of what? Of oxygen. So we can use it to find, so we can use it to solve. So I'm not going to replace this n and put what m over what capital M. So I'm going to have PV is equal to mass over molar mass RT. I hope this is clear. So now let's continue. It is oxygen. You know that the molar mass of oxygen is 16, and because since they said oxygen gas is what is O2, and O is 16, so I'm going to have the molar mass as what 16 times 2. Oxygen gas is what O2 is a diatomic gas, it has 2, so it's going to be 16 times 2. So the molar mass of oxygen is going to be what 32 gram per mole. Take note of that. Yes. So now let's apply it to our formula. So I'm looking for V, and V is unknown, times V is what? V is where is it? V is 2.5 times 2.5 is equal to the mass of the gas is 16 gram. 16 over the molar mass is what 32 times R is what? R is 0.0821, right, times T is 300 times 300. So I'm going to have 2.5P is equal to 16 year 1, 16 year 2. This is 1 over 2. 2 year 1, 2 year is 150. So I'm going to have 0.0821 times 150. I divide both sides by 2.5, right, over 2.5. So I'm going to have P is equal to, let me use my calculator. P is equal to, so I have 0.0821 times 150 divided by 2.5. Yes, so my answer is going to be 4.926. Yes, 4.926 atm atmosphere. Now let's solve this one real quick. They said what is the temperature of a given mass of gas initially at 50 degrees Celsius. It means that its first temperature was 50 degrees Celsius. So T1 was initially at what? 50 degrees Celsius converted to Kelvin plus 273. Abi? Yeah, so what was 50 plus 273? So I'm going to have 323. Yes, Kelvin. 323 Kelvin. So let's say that what is the temperature of the gas initially at what 50 degrees Celsius and 18 atmosphere. So P1 here is what 18 atmosphere, right? If the pressure is reduced to what? To 6 atmosphere. Now the pressure was reduced to what? 6 atmosphere. So P2 was now reduced to 6 atmosphere. That's 6 atm, right? So what they say again? At constant volume. So the volume is constant. So that's how to calculate the temperature of the given mass of the gas. So that's T2. And that's how to find T2. Now you can see that I'm giving temperature, I'm giving pressure, right? So and the formula that is linking pressure and temperature, I know that okay, I did not give you a formula to link the two of them. I mean, see what you will do. Now if you remember, I told you that P1 V1 over T1 is equal to P2 V2 over T2. Now if you read in the question, they told us that what the volume is constant. It means that V1 is equal to V2, so it is out. Since they are the same, they will cancel out. So now I'm not left with what P1 over T1 is equal to what P2 over T2. I hope this is clear. It should be. Yes, now let's move on. So now, how am I going to do it now? So P1 is what? 18. So I'm going to have 18 over T1 is what? 323 is equal to P1 and P2 is what? P2 is 6 over what? Over T2. Abi, if I decide to cross multiply, I'm going to have 18 T2 is equal to 323 times what? Times 6. Divide both sides by 18 over 18 over 18. 18 short 18. I'm going to have T2 is equal to, now let me use my calculator to get that. So I'm going to have 323 times 6 divided by 18. That's going to be what? 107.67 Kelvin. Yes. So this will be your answer. Let's solve a new question. So now let's solve this question. They said here that if the pressure of 200 centimeter cube is half, what will be its new volume? Now listen. They said that the first volume V1 is what? 200 centimeter cube. Listen, understand question. If the pressure of 200 centimeter cube is half, it means that the pressure, I just assume P1 is what? Is X, Abi is not given. And they say that P2 is half. The pressure is now half. So it means that P2 is going to be equal to half of what? Of P1. Listen to the question again. They say that if the pressure of 200 centimeter cube is half, so the pressure was half of the initial one, Abi. Understand question, no? Okay, so they now say that what will be its new volume? So I'm looking for what? V2. Now, what will be V2? That's just the question. Now, if you can remember, I told you that V1, P1, V1, it's the same thing. P1, V1 is equal to P2, V2. Abi, so P1 is what? X times V1 is what? 200. Abi is equal to P2 is what? X over 2 times what? Times V2 is what I'm looking for, V2. Now, according to mathematics, X can cancel X. For you guys that don't know that X can cancel X, I'll just solve it. I'll continue solving it to go up. I'll not cancel it here, so it's not confuse anybody. But you know that X can cancel X at this point. Hope you know that. So I'm going to have, if I cross multiply, I'm going to have 2 times all this nonsense here. So I'm going to have 400X is equal to V2X. Since I'm looking for V2, I'm going to divide both sides by X over X. X will cancel X. X will cancel X. So V2 is equal to what? Is equal to 400 centimeter cube. Simple. What if I told you that there's an easier way to solve this without even doing much calculation? Now, how am I going to do this? In case you see a question like this in your JAM. Now, listen. They said that, I'll read the question again so you understand. They said that if the pressure of 200 cm cube is half, what will be its new volume? Now, they said that the pressure is half. The first thing you ask yourself, what is the relationship between pressure and volume? If you can remember, I told you that pressure is inversely proportional to what? To volume. It means that if the pressure is increasing, this one will be decreasing. If this one is decreasing, this one will be increasing. They are inversely proportional. You understand? Anything that happens to this one, the reverse will happen to this one. Anything that happens to this one, the reverse will happen to this one. So if I increase P by 2, this one will be reduced by what? 2. If I increase this one by 4, this one will be reduced by what? 4. If I increase this one by 5, this one will be reduced by what? 5. So now they told me that the pressure is halved. The volume was initially 200, and I said that the pressure was what? Was halved. So if the pressure is halved, it means that this one will be what? Multiplied by what? 2. To be halved means to be divided by 2. Then I'll just multiply it by 2 because the reverse is the case, because they are inverse. So the answer is what? 400 centimeter cube. You don't have to calculate. Easy peasy. Now let's solve the next question. Now I keep on saying this, out of audio science subject, chemistry is one of the easiest subjects. Out of audio science, so chemistry is very, very easy. Now let's solve this one. They said here that a gas occupying an initial volume of 2 dm cube. So initial volume, so V1 is equal to 2 dm cube. Is heated and allowed to expand to 6 dm cube. So V2 here is equal to what? 6 dm cube. Yes, at constant pressure. Okay, nice. They answer that what is the ratio of the initial temperature, initial absolute temperature to the final absolute. So that's not for the ratio of T1 initial to final abi initial, so the answer for the ratio of T1 to what? T2. This is simple, there's no big deal there. Now, so what am I going to do now is that that's just for the ratio, abi? Yes. Now, what formula is linking V and T? That's Charles law, abi? That's V1 over T1 is equal to V2 over what? Over T2. Now, since I'm looking for the ratio of T1 and T2, I'll bring them together. That's the ratio of T1 to T2 is the same as saying T1 over T2, abi? Yes, so I can, it's mathematics, so I can bring this T1 over here and bring this V2 over here. It's mathematics, I can swap, you understand? So I'm going to have V1 over what? V2 is equal to what? See, I swap them. T1 over what? Over T2. So that's math. See, swapping, we are swapping. So now I have T1 over T2, abi? So now T1 over T2 is going to be equals to V1 here is what? 2 over what? V2 here is what? 6. So 2 here 1, 2 here 3. So T ratio T2, T1 ratio T2 is the same thing as saying 1 ratio 3. So this is your answer. Chemistry is very, very sweet and easy. Let's have the next question. Now let's move to the next question. You see that chemistry is sweet, sweetened it. Yes, it is sweetened. I'm just playing no big company. Now let's move to the next one. They say that the temperature of a gas is 37 degrees Celsius. So T1 here is equal to 37 degrees Celsius. Yes, I'll have to convert it now. Plus 273. I'll be plus 273. So now I'm going to have 310 Kelvin. Yes, 310 Kelvin. So that's 310 Kelvin. So now what did I say again? At what temperature? So that would be T2. At what temperature would the volume be halved while the pressure be quadrupled? Now I'm going to, like I did our other one, I'm going to solve this in two ways. The easy way and the what? And the normal way. The easy way is quite, I'll make sure it's not going to confuse you, but if you have brain, you understand, and I'm sure you have brain. So now let's first do the normal way, the normal style. Now let's go. Now they said that, I'll read the question again. They said that at what temperature would the volume be half? So now would the volume be half? It means that if V1 is equal to, listen, if V1 is equal to X, or should I use X? Okay, let me just show you. If V1 is equal to V, it means that V2 is equal to V over 2. Just try to apply mass and wisdom together. If V1 is equal to V, it means that V2 is equal to V over 2. And the pressure be quadrupled. Quadrupled means over 4 now. Yes. So if P1 is equal to P, it means that P2 is equal to what? P over what? Over 4. Shikina. So now, which one am I going to use to link all these nonsense idiots together? That's going to be P1 V1 over what? Over T1 is equal to P2 V2 over what? Over T2, right? Yes. So now my P1 here is what? Is just P. My V1 here is just V, abi, you can see, over T1. T1 is what? 310. It's 310. That's going to be equal to P2 here is P over 4. P2 is P over 4. P over 4 times V2 is what? V over what? Over 2. All over T2 is what I'm looking for. I'm looking for T2 now. Now, like as I've said, this one can cancel this one out. This one can cancel this one out. Abi? So I'm going to have 1 over 310 is equal to 1 over 4 times 1 over 2, abi, all over T2, right? Yeah, so I can just decide to cross multiply. I don't want to confuse you. I can just decide to cross multiply like this. So this one multiply this one multiply everything here. So I'm going to have T2 is equal to 310 times 1 over 4 times 1 over 2. You can say I'm solving it one so you understand. So T2 is equal to what is 310 divided by 4 divided by 2? Let me use my calculator. So 310 divided by 4, that's 7.5 divided by 2, That was what 38.75. So that would be 38.75 Kelvin. Yes. So now this is what method 1. Now the easiest way to solve this, as long as you know the relationship between temperature and volume and temperature and pressure, you should know that yes, you can use your brain to solve it. Now you know that temperature is directly proportional to what? To volume. So volume is directly proportional to temperature. I've given you this before, and there's a formula I derived one formula. I told you that P1 over T1 is equals to, so you should know that temperature is also directly proportional to what? To pressure. So anything that happens to the temperature is same to what happens to the volume. Anything that happens to the pressure is same to what happens to the temperature. So for example, if I increase the volume by 2, the temperature will be increased by 2. If I increase the pressure by 2 or decrease it, same thing will happen with the temperature, since they are directly proportional. So if you read the question, I guess the question said that the volume was halved. Abi? Now the temperature was initially at what? At 310 Kelvin, abi? And the volume was what? Was halved. If the volume was halved, it means that if anything that happens to the volume, the same thing is going to happen to the what? To the temperature. Listen, anything that happens to the volume is the same thing will happen to the what? To the temperature. So T1 is equal to what? To 310 initially, but the volume was halved. It means that this one will be halved, abi? So what is now 310 divided by 2? That's going to be equals to 155, abi? Yes, I've gotten that one. And the next was that the pressure was what? Quadrupled, was divided by what? 4. It means that okay, I'm still going to, since the pressure was quadrupled, anything that happens to the pressure will happen to the what? Temperature. So I'll now divide by 4 again. I'm not going to get what? 38.75 kg. I'm going to get what? 38.75 kg. That's simple. So if you don't understand this one, you can actually use this style. Very, very accurate and very, very demure. Let's move to the next question. So now let's solve the next question. We have light now, so that's why it's a little bit bright. Now the next question, where is it? The next question says that 0.79 gram, 0.79 gram, which is the mass, 0.79 gram, right, of a gas at STP, okay, occupy the volume. So V is equal to 250 centimeter cube. Abi, then now to calculate the molar mass of the gas, the molar mass, the relative atomic mass, that's Rm, that's written as molar mass. So that was calculate M of the gas, Abi, and R is given to us, so only going to be given to you as 8.314 millimeter mercury, blah blah blah. You understand? Yes. Now, if you notice, the formula I gave you was PV is equal to N out. I know that N is same thing as saying mass over molar mass. Abi RT. Abi yes, RT. Now listen and listen very good. P is not given here, but if you look at the question, they said at STP, and at STP, P is equal to what? 760 millimeter mercury. Take note of that. Take note of that. So now I'm going to have 760 times V is what? 250 is equal to M is 0.79 over this M that I'm looking for. R is what? Times 8.314 times T at STP. T is what is given to us. So T at STP is equal to 273. I mean 273 degrees Celsius at STP. That will be times 273 degree Kelvin. Anyone you want to use anyone. So now I'm going to multiply. If I could multiply now, I'm going to have to multiply everything. I'm going to have 760 times 250 times M is equal to everything. That will be 0.79 times 8.314 times 273. Abi? Yes, let me use my calculator. So now, since I have M, I'll divide both sides by everything beside the M. So I'm going to have M is equal to 0.79 times 8.314 times 273 all over 760 times 250. So now let me press my calculator. 0.79 times 8.314 times 273, right, divided by 760 divided by 250. So I'm going to have 9.437 times 10 raised to power what? Minus 3. So this is the what? The molar mass. That will be gram per mole now. Gram per mole. Yes. So this is the final answer in graph. But if your answer is in decimal points, not in standard form, so something like this: 1, 2, 3. That would be 0.00943 times 10 raised to power. You understand? Yes. So that's. Let's solve the next question. So now let's solve this last question. This will be the last question. Yeah, let's solve it. They said that 30 centimeter cube of a gas. Make sure you are liking the video. Like, comment, and share. Or else, if you watch the video finish, you know, like everything you watch, you'll forget it. I'm just kidding, but just make sure you like it. So now they said that 30 centimeter cube of a gas was collected over water. Collected over water. This is something different. Okay, let's go. They say 30 centimeter cube of a gas was collected over water. So V1 is equal to 30 centimeter cube. Was collected over water at 30 centimeter at 30 degrees Celsius. Sorry. So T1 is equal to 30 degrees Celsius plus 273. Plus 273. That's going to be equals to 303 Kelvin, right? And what 760 millimeter mercury. So P1 is going to be equals to 760 millimeter mercury. Calm down. This is not the P1, but I just want to write the data down. This thing. So now they now say that what is the volume of the dry gas? So V2. Let us find V2. What is the volume of dry gas at STP? And at STP, at standard temperature and pressure, the temperature is equal to 273, while 273 Kelvin, while the pressure is equal to 760 millimeter mercury. Now they have to calculate the volume of the dry gas, and what is given to us? The volume of the dry gas, and what is given to us is the pressure of the gas that is collected over water. If a gas is collected over water, it's not going to be dry and to contain some, you understand. So now, to calculate the first pressure minus the saturated vapor pressure of water, I'm going to get P1. Now listen, they said that 30 centimeter cube of a gas was collected over water at 30 degrees Celsius and 760 millimeter mercury. What is the volume of the dry gas at STP? In brackets, SVP, which is the saturated vapor pressure of water at 30 degrees Celsius, is what? 32 millimeter mercury. So now they told us that the pressure of the gas that is collected over water is what? 760 millimeter mercury, and the saturated vapor pressure of water is minus 32. So to get the main pressure, I'll subtract the SVP of water from that will be what? Minus 32 millimeter mercury. That's all. So now automatically my P1 is going to become, what is 760 minus 32? That will be what? 728 millimeter mercury. Yeah, that's it. So I have DTP. So I'm going to use the formula V1, or let me just say P1 V1 over what? T1 equals to P2 V2 over what? T2. Yeah, very simple, very demure. So now I'm going to have P1 is what? 728 times V1 is what? 30 over T1 is 303. That's equal to P2 is what? P2 is 760 times V2 is what I'm looking for, over V2 over T2. This is T2. This is P2. So T2 is what? 273, right? Because multiply the idiot. So at the end of the day, I'm going to have V2. Let me just go to the point. V2 is going to be equal to This one plus that will get to be 728 times 30 times 273 over all this one that is beside. I divide both sides, that will be 303 times 760. So I'm going to have 728 times 30 times 273 times 273 divided by 303, that will be equal to divided by 760. So I'm going to have 25.89 centimeter cube. That's that chemistry is sweet. Now our paid class is ongoing, our jam class is ongoing, and the fee is just 4,000 naira. Make sure you don't miss out from it. So now this is just the part 1. Part 2 is going to be dropping soon. Make sure you solve past questions, and if you have any question, drop it in your comment section. Any topic you want me to treat next, drop it in the comment section. See you in our next video class course. God bless you.